Hello, am I audible to you? Good evening, all. Hello.
Good evening, sir. Yes, audible.
Okay. So I think we shall start. Okay. So today's class, we are going to discuss about machine design. In some way, we say design of machine elements. Okay. So this is a basic thing when you study mechanical engineering. Okay. If you are a graduate in a mechanical engineering, or if you have studied mechanical engineering or diploma in mechanical engineering, so the main subject what we go through is machine design or design of machine elements. So we have seen many elements over there. So what does this mean? How will you design an element? That is what a mechanical element. What are the steps and procedure in designing an element? That is what machine design explains. So first we are going to the introduction to design. In that, the first thing is basic design consideration. Then second thing is design procedure, general consideration in design, types of load, stress strain diagram, type of stresses, concept of creep, fatigue, SN curve, entrance limit. These are the basic things what we are going to discuss. Okay, don't worry about all those things. When we shall discuss each and everything, we will understand what is this basically. So first we will be going with design procedure. Then what are the consideration what we do in design? Then what are the types of loads that are acting? Then we will be explaining the stress strain diagram. Then types of stresses, concept of creep, fatigue, SN curve, and entrance limit. These are the things what we are going to discuss. So I have told you, if you study any engineering subject, there will be a course outcome. So course outcome, if you see the syllabus of engineering subject, you will say different CO. CO means course outcome. So what are the outcome of this course, or what you are getting as the outcome? That is CO. So course outcome is, first one is analyze and evaluate the loads, forces, stress involved in components and design the dimension. So what are the forces acting in this thing, and what are the, how will you decide the dimension? Select design criteria for different machine components. That is how to design a different machine component. That is what second step is. Third is select proper materials for machine components. Fourth one is identify the various modes of failure of machine components under different load patterns. Then use design data book and IS codes for design. What is IS? In this, what is IS? Do you know what is IS? IS means Indian Standard Codes. Okay. Indian Standard Codes for design. Select standard components with that specification as per design. Okay. So what are the different types of failure in a machine? It can be due to force, stress, fatigue, creep. Okay. These are the various failures that can occur, etc. There. So that is what are the failures which may happen. Okay, under different load patterns. So we have to first you have to study what are the different load patterns. Then only we will understand what are the failures. So by the course outcome, the first thing is we are analyzing the loads, forces, and stress involved in the components and decide the dimension. Next is select the design criteria for different machine components. Then select proper material for machine components. Next, identify various modes of failure of machine components under different load pattern. Use design data book and different IS codes for design. Select standard components with their specification as per design. This is the thing what is basically the course outcome of this subject. Okay. So first is design procedure. We have discussed from the first class itself what do you mean by first. When you start from the class, the first thing is design procedure. In the first slide, we have discussed about design procedure. So we will start from the first thing is design procedure. So what is need or aim? What is our aim? Okay. For example, our aim is to design a site. For example. So what is our aim? Site. Okay. So that is what need. Or what is the need? We want a rotary motion. So that is the need. For what kind of materials can be used. So for example, our need is to construct a cycle so that we can move from one place to another. So we have found out our need or aim. That is the first thing, aim design of it. For example, here we are going to cycle. Next is synthesis or mechanism. Where you have studied this, you have already studied this in theory of machine. Okay. What does this mean? Synthesis of mechanism. What are the different mechanisms involved in designing a cycle? For example, here we are considering cycle. So what are the disturbed forces or coming over there? That comes under synthesis of mechanism. Then third one is analysis of forces. What are the forces acting at that? We have to analyze the forces. So these are the first three things. The first thing is need or aim. Second one is synthesis of mechanism. Third one is analysis of forces. So I think this up to this it is clear. Now the next thing is we have already analyzed the forces and we have understood that this much is our aim. These are the synthesis. What are the forces? How many links are there? We are calculating how many degree of freedom. Everything we have calculated. Then we have analyzed the forces. Now you have to select the proper material as per the forces. That comes under material selection. Okay. Then after selecting the material, you have to design the elements, size, shape, stress, etc. Okay. Then any modification is that you have to do that, and you have to draw a detailed drawing. Okay. Then after drawing you have reached to detailed drawing, then only we can forward this to the production step. Okay. So you should understand that these are the steps in the design process. First one is need or aim. First one is need or aim. Second is synthesis of mechanism. Third one is analysis of forces. Fourth one is material selection. Fifth one is design of machine elements. Then next is modification. Next is detailed drawing and production. Okay. After the drawing is set up only, it will be moving to the production phase. Okay. Now this is known as the design procedure in machine design. Okay. This is an important criteria when we start machine design or design of machine elements. Okay. Both are same only. Machine design or design of machine elements. So the design procedure comes under need is where what is our need. We have to identify what is our need. Then you have to do the synthesis of mechanism. What are the mechanism over there? Then what are the forces acting there? After that, you have to select the proper material. Then you have to design of elements, size, shape, stress, etc. Then if any modification is there, you have to incorporate that. Then detailed drawing you have to make and you have to move to production. I think this step is clear for you. Okay, now we will move to next step. Next comes under general consideration in design. That first step is type of load and stresses caused by the load. This is the first step. What are the type of load and what are the stresses caused by the load? Okay. Then second thing is motion of parts or kinematics of machine. Okay. What do you have to know? How it is moving. Then selection of materials. Then form and size of parts. Friction resistance and lubrication. Convenient and economical features. Use of standard parts. Safety of operation. Workshop facilities. Number of machines to be manufactured. cost of construction and assembly. Okay, these are the general considerations in design. When you design a material element, first you have to calculate what are the types of loads and stresses caused by that load. What are the load is there? Okay, if a tensile load is there, tensile, what do you mean by tensile? Okay, you have to understand that this is the component, and if a force F is acting like this, that means it is just pulling a component. What type of force is happening here? Tensile force. Tensile. Okay. Similarly, if a component is there, and if you are pushing that component from both the ends, what type of force is there? Compressive force is there. Okay. If there is a component like this, if you are pulling from both the end of the components, this here what happens? Shear force will act. So the material will be splitting from this side. Okay, that is known as shear force. Okay, so so first consideration is what are the type of load and stresses caused by that load. Then motion of parts or kinematics of machine, how the motion is happening. Then how to select the materials. Then form and size of parts, frictional resistance and lubrication, convenient and economical features, then use of standard parts, safety of operation, workshop facilities, number. That means what is that? So you have to select the material. Then form. How will you select the material? The material should be selected in such a way that it should have good quality. Okay, quality and standard. But also the cost should be, if it is of high cost, okay, then what happens? The total production cost will increase. Okay, so the materials should be selected in a way that should be of good quality but of medium rate. Okay, but if some materials will be available only at high rate, we have to purchase that, but we have to compare it. Then what are the form and size of the parts? Then what are the frictional resistance and how to lubricate this, or how much lubrication is needed? Then what are the convenient and economical features? Then always you have to use standard parts. Why the specialty of standard parts? You have heard a term about interchangeability. Let me. So there is a word known as interchangeability. That means if you are not using standard parts, we will not, if there is a defect, we cannot replace it. Okay, so use of standard part is very important. Okay, then the safety of operation, then what are the workshop facility needed, how number of machines to be manufactured, machines or components, how you are using, what you are going to produce, that is important. In some cases machine will produce, some cases components will be produced, depending upon that what you have to manufacture. Then cost of construction and assembly. These are the consideration what we keep in mind when we are using or designing an element. Okay, I think the concept is clear. Next is types of load. Okay, so types of load, in that first load is dead or steady load. Okay, so a load is said to be dead or steady. What is the specialty? When it does not change in magnitude or direction. That is, if 100 kg Newton is 100 Newton load, sorry, not 100 kg Newton, sorry, 100 Newton load or force, whatever it may be acting on a system. If it is not changing, it comes under dead or steady load. Okay. Live or variable load is, the load may be live or variable, it changes continuously. Now it's 100. After 10 minutes, it may become 110. Sometimes it may go to 90. Sometimes it may go to 160, like that. So when this load is changing, this is known as live or variable load. Then suddenly applied a shock load. Shock load means a load which is acting suddenly. Just it will act and it will be removed. That type of load is known as shock load. Okay, for example, electric shock. What is that? If we are just keeping an electric wire to our hand, we will find the shock. No, that is not a shock load. That is, it is acting, suddenly acting and removing. Okay, that type of load is known as shock load or suddenly applied. Then impact load is that when we are applying a load with some velocity, that type of load is known as impact load. It will be having some impact on that material. Sometimes it may remove that, it will make that material to move some distance. Sometimes it will help that material to go down, so etc. These type of loads are known as impact load. A load is said to be impact load when it is applied with some initial velocity. So you know what is velocity? Distance by time will give you velocity. Okay, so velocity. Okay, so that is what some initial velocity. When a material impact load means when a load is said to be impact when it is applied with some initial velocity. Okay, so these are the types of load. What is dead load? That is dead load means it is acting. It will not be changing its magnitude or direction. Okay, so that type of load is said to be steady load. Live load means it can change continuously. It can change the magnitude as well as direction. Then suddenly applied or shock load. A load when it is suddenly applied and removed, that comes under suddenly applied or shock load. Impact load means if some load is acting with some initial velocity, that type of load is known as impact load. I think you are clear with this type of loads. Okay. Next is stress strain diagram. So have you heard about stress strain diagram? Stress strain diagram. Do you know what it means? Stress, strain, etc. So before going to that, this is stress strain diagram. You may heard about two types of material. One is ductile material, another one is brittle material. Okay. So these are the two types of material. If you simply say ductile means it will be breaking. For example, if you are having a specimen of ductile type, okay, what happens when a load is applied to this material? Okay, it will withstand the load up to its elastic limit. I think it's clear. After that, what happens is that a neck will be formed, starting forming in the ductile material. And at last, it will break. Okay, that is the specialty of this ductile. Okay. Then, when you are using brittle material, can you give an example for brittle material? Simply you assume glass. Okay. If what happens after the elastic limit is reached, the glass will break. Suddenly it will break. Okay. There will not be any neck formation or etc. It will break. That is specialty of glass. Glass and cast iron are the examples of brittle materials. Okay. You have to understand that glass. So I think the concept is clear, no? Any doubt? Okay, I think the concept is clear, no?
Yes, sir. Clear.
Shall I proceed? Stress strain diagram. So gold, silver, etc. comes under this ductile material. Now you have to study the stress strain diagram. Okay, before going to that, you have heard about MS steel, mild steel. This is MS steel, mild steel. Okay, this is an example for ductile. Okay, now first what you have to do is you can see stress strain diagram over here. If you are naming it as A, B, and this is C. Okay. For example, just for our convenience, this is stress strain diagram. You have to understand that when you are saying anything like this stress strain diagram, okay, this is for your reference. Okay, stress will be in y-axis, strain will be in. You have to understand that. Okay, whatever set will be in the y-axis, and the second part will be in the x-axis. Okay, so stress, this will be strain diagram. Okay, so we have started applying load on a specimen. We have got a specimen and we have started applying the load on the specimen. Okay, so what happens is at point A, okay, it will reach the what type proportionality limit. Okay, so it will be up to A, it will be proportionality limit. Okay, up to B, it will be elastic limit. Okay, then C will be the yield point. Okay, and D will be the ultimate stress. Okay, after this point, what happens? Breakage will happen. Okay, so what is the specialty up to elastic limit? Elastic limit. Up to elastic limit, you have to understand that stress is directly proportional to strain. Okay, up to elastic. Okay, after the elastic limit is reached, after it will have the ultimate stress. After ultimate stress, if you again apply the load on this material, what happens? Neck formation will start and it will break. Okay, that is the specialty of this mild steel or ductile material. If it's a brittle material, after the yield point is reached, it will break. Okay, still clear? So this is the specialty of stress strain diagram. So first, before we are going to explain this in little more detail. Okay, this is basically stress strain diagram. So now you will be having some confusion regarding here and there, but when you study these stresses, now you will be clear with these things. Okay, we will do that. First, we will go with the stresses. So next is types of stresses. Okay, shall we start? I think clear, no? Next is types of stresses. In that first one is stress, strain. Sorry, types of stresses. In that one is tensile stress. I have told you tensile stress. Okay. So I have told you in the before the class itself what we mean by tensile stress. When we are having a specimen like this, and if you are applying equal and opposite pull on that material, you will get what type of stress? Tensile. Okay. So the load is known as tensile load. P is known as tensile load, and the stress you are getting is tensile stress. And tensile stress, the equation is load by area. Okay, the equation for stress is load by area. When tensile force is acting, what type of stress you will get? Tensile stress. Okay, so by definition, you can say when a body is subjected to two equal and opposite axial pulls P, then the stress induced at any section of the body is known as tensile stress, and tensile stress is load by area. What is strain? Strain is always change in length divided, so change in length divided by original length. Okay, these are the two things. You have to understand that stress is equal to load by area. Similarly, strain is equal to change in length divided by original length. Okay. Okay, now these are the definition of stress and strain. Okay. you have to always understand that within the elastic limit, stress is directly proportional to strain, and this law is known as Hooke's law. Okay, so Hooke's law states that within the elastic limit, it's an important criteria. Within the elastic limit, stress is directly proportional to strain. That is what Hooke's law states. Okay, from that only we will be getting a value known as Young's model. Okay, that we will study when we study about strength of materials. But I have just, since the definition I have written over here, tensile stress and tensile strain, I have explained that. So tensile stress means tensile load by area. Similarly, tensile strain is change in length divided by original length. Okay. Now compressive stress. Now this is compressive stress. Stress is when we are having equal and opposite push from two ends of the material. The stress induced at any section of the body is known as compressive stress, and compressive stress is load by area, and compressive strain is change in length by original length. One thing you have to understand that when there is a pull from both ends, what happens? The size may reduce. But when you are pushing from both ends, the size may slowly increase, slightly increase. Okay, so that is a difference. Here, compressive strain is change in length divided by original length. Also, compressive stress is load by area. So whatever it may be stress, you have to understand that the equation of stress is load by area. Okay, stress is always represented by load by area. Okay, I think the concept is clear. Next, you are going to have shear stress. Shear stress in the definition, first class definition itself, first slide, in the definitions I have told you what you mean by shear stress. There is a material over here, there is another material over here. They are connected. And if you are pushing from both the material, you are just having a pull. What happens? The condition of material is to break from this point. Okay, this type of stress is known as shear stress. Okay. When a body is subjected to equal and opposite force acting tangentially across the resisting section, that is, this is known as the resisting section. Okay. As a result, the material body tends to shear off the section. It will shear from this section. Then the stress induced is known as shear stress. Okay. Shear stress is also force by area, but here tangential force. So shear stress is always represented by tau. It is equal to tangential force divided by resisting area. Okay. Tangential force divided by resisting area. I think the concept is clear. Okay. This is known as shear stress. Okay. When a body is subjected to two equal and opposite forces acting tangentially across the resisting section, as a result of which the body tends to shear off from the section, then the stress induced is known as shear stress. Okay, concept is clear now. Then you have to understand one more thing. If it's a shear stress or stress, whatever it may be, stress is equal to force by area. So P by area, how will you represent? Pi by 4 d square. So when you represent 4 P divided by pi d square will be the equation for stress. Okay. So pi, how is area? Area equation is pi r square. Okay. Pi into r is what? D by 2 the whole square. Okay. That is how it will be coming as pi by 4 d square, if any doubt is there. So this is stress is load by area. So P by area is pi by 4 d square. So when this 4 to upper side, it will be 4P divided by pi d square. I think the concept is clear for you and the equation. Okay. Shall I move to next part? Okay, so I shall move to the next part. This is double shear. Double shear means this comes under rivet. So rivet is a, what you mean by rivet? It will be a rivet are used to connect two materials, two or three materials. You can see here, this portion is the rivet head, and there will be shank portion here like this. Okay, this is known as a rivet. Okay, so the area of resisting of shear rivet. So here means two double shear is there. From both the end, it will break off. Okay, that is why double shear is there. Okay, so it is nothing but 2 into pi by 4 d square will come area. So what happens in place of 4p, it will be 2p divided by pi d square will be your equation. Why? Because simply what is area? Area is equal to pi by 4 d square. So 2 are there, double shear are there. So into 2 is equal to pi by 2 d square will be the total area. So when you substitute here in place of 4, it will be only 2. So when this 2 go to upper side, it will 2p divided by pi d square. Okay, that is the case when it comes to double shear. Okay. Next is crushing stress. Crushing stress means if what happens, you may see a localized compressive stress is acting here. Okay, at the surface of contact between two members of the machine parts. Then at rest, okay, then what happens? Crushing. Here crushing will be happening. Okay, so this type of stress is known as crushing stress. Okay, so the equation is P divided by dTn. D is the projected area of the rivet. D into T is the projected area of the rivet, and N is the number of rivets that we are using. Okay, T is the load. Okay. So this will be acting in localized area. That means if you are having a rivet portion like this, and we are connecting this rivet portion here, two materials are connected by this rivet over here. Okay, so by this rivet only it is connected. Here only this compressive stress will act. Okay, in that area that is localized area, and it will crush this area. Okay, that is known as crushing stress. So bearing stress means here it is rotating. This part is rotating. Okay, and what happens when there is a rotating part? Here, when the stress, compressive stress is acting over here. Okay, when two localized compressive stress act at the surface of contact between two machine parts that which have relative motion, then forms what type of stress? Bearing stress. Okay, so when this is known as fixed bearing, and there is a rotating journal inside over here. So when journal rotates, there develops a compressive stress in these portions. Okay, what happens? This can create what type of stress? Bearing stress. I think the concept is clear. Okay, that means when at rest, when compressive force is acting in the localized area, it forms only crushing stress. But here what happens? This bearing is rotating, and this another fixed bearing is there. When this force acts between this fixed bearing and rotating journal in this portion, when compressive stress acts, what type of stress is developed? The stress developed is known as bearing stress. Okay, no? Okay, the concept is clear now. You have to understand that this material should move here. It is rotating and compressive stress should act. Then what type of stress will be developing? Bearing stress. Okay. PB is equal to P divided by L into D. L is the length of the journal in contact and D is the diameter of the journal. So length is only up to this much. Okay. And D is the diameter of the journal. Okay, I think the concept is clear. Okay. 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 Then next is torsional shear stress. So you have to understand that when a machine member is subject to action of two equal and opposite couples acting in the parallel planes or a torque or a twisting moment, then the machine member is subjected to torsion. The stress set up by the torsion is known as torsional shear stress. Equation is tau by R is equal to capital T by J is equal to C theta by L. Okay. For example, you may see here what happens when a shaft is rotating. For example, if this is a shaft is rotating and there is a torque like this acting in this shaft material. Okay. So this torque will, you can see, develop forces, okay, stresses in this material. This type of stress is known as torsional shear stress. For torsional shear stress, what happens? Two equal and opposite couples, torque or twisting moment should be there. Then only what type of shear stress will develop? Torsional shear stress. Okay, so that is important. Okay. Tau is shear stress, R is the radius, capital T is torque, J is polar moment of inertia, C modulus of rigidity, theta angle of twist, L is the length. Okay, I think it's clear, all the portions. Torsional shear stress. Now to develop the torsional shear stress, what happens? There should be a twisting moment or torque. Okay. Next is bending stress. Bending stress is the machine parts or the structural members may subject to static or dynamic loads, which may cause bending stress in the sections besides other type of stresses such as tensile, compressive, and shearing stress. Okay, bending stress is represented by M. Okay, what happens? A bending moment is developed here. Okay, bending stress is developed here. For example, for a bridge. For example, a bridge is there. So when this what happens when wait, but in bridge case it is not a machine, but we are saying that if, for example, if there is a bridge over, okay, when the vehicles are passing through this bridge, what happens? There will be a bending stress bending in this bridge. Similarly, for machine components, when that means static and dynamic loads are acting on these machine parts, what happens? There may be bending stress developed in the machine components. This bending stress will produce what happens? If the bending stress is very high, what happens? The machine will fail. Okay. For example, propeller shaft, etc. What happens when it is rotating? There are, you might have seen propeller shaft of a vehicle. When it is moving through this road, always what happens? The stress is developed. And if that stress developed is very high, what happens? It can lead to failure of the material. Same is the case with bending stress also. Okay, so if the bending stress reaches the maximum value for the machine component, what happens? It will surely fail. Okay, so that is the case with why we are studying about these stresses. That is what I was explaining. So we have studied different stresses throughout the class, but the specialty of these stresses is that whatever stresses is developed, and if it is reaching the maximum limit, what happens? The failure will surely happen. That is the case. Okay. So now we will go back to stress strain diagram. That this one. So that I can write it again. Okay, please wait. Stress strain diagram. So here, stress strain diagram. This point A, sorry, this point A is known as the proportionality limit. Okay, is it clear? Up to proportionality limit, it will obey Hooke's law. What is Hooke's law? Within the elastic limit, stress is directly proportional to strain. This is what Hooke's law. Within elastic limit, stress is directly proportional to strain. That point is known as proportionality limit. I think the concept is clear. Okay. Then this point B is known as the elastic limit. Okay. Elastic limit. Okay. Then C is the yield point. And D is the ultimate stress. Okay. Then E is the breaking stress. F will be the fracture point. Okay. If it obeys, if the ductile material, what happens? Up to A, it will, whatever stress is there, it will be directly proportional to strain. After that, up to B, it will reach the elastic limit. Elastic limit means it will stand the maximum load over there. After that, yield point will be reached. Okay. After yield point, what happens? The stress we get is known as the ultimate stress. After ultimate stress is reached, what happens? Now the material has undergone the maximum force or the maximum load it can withstand at the ultimate stress. After that, if you apply the load on that material, what happens? The material will break. That point is known as E. And next point is F, where the material will fracture. Okay. So if you are doing this on a material, ductile material like this, so what happens? So up to elastic limit, it will obey. Stress is directly proportional to strain. Okay. There will not be any change in specimen. Okay. But after the yield point is reached, if we again apply the load, you can see here what happens. The neck formation will start. Okay. So after the neck formation is started, if you are again applying the load, what happens? Ultimate stress will be reached and the material will break. Okay. So that is what this is explained as stress strain diagram. So up to A, it is known as proportionality limit. B is the elastic limit. C is the yield point. D is the ultimate stress, and E is the breaking point, and F becomes the fracture point. Okay, these are the 6 points in a stress strain diagram. Okay, this is very important in design because if you are not applying the load which is up to the elastic limit in a machine design, what happens? The design may fail. Okay, if the load, the intensity of load increases while designing a material, and when the working starts, what happens? The failure, the chance for failure is high. If it is designed up to ultimate stress, what happens? It will surely fail. Okay, so the design, this stress strain diagram is very important in designing a machine component. Okay, so these are the properties of IXX, IYY. Okay, this is for your reference only. Okay, these are the commonly used cross-section areas: rectangle, square. If rectangle, moment of inertia IXX is BHQ by 12, and IYY, about y-axis, the moment of inertia is HBQ by 12. Similarly, section modulus is BH square by 6 and HB square by 6. If the square, similarly, moment of inertia is B raised to 4 divided by 12, and section modulus is BQ by similarly triangle. Okay, you can use this for only reference. Okay, so these are the things what we are basically used in designing. Then hollow rectangle is there, hollow square is there, circle is there, hollow circle is there. Okay, these are the basic things when we use for designing a machine element. This is for your reference, you can use this one. Next is principal stress and principal strain. Okay, so what I mean by principal stress? So principal stress. What you may pronounce it as principal stress. Okay, the stress in which the planes in which no shear stress is there is known as principal plane. Okay. Okay. The planes which have no shear stress is known as principal planes, and the direct stresses along these planes are known as the principal stress. Okay. Shear stress will be equal to 0. Okay. Planes in which the shear stress is 0, that is known as principal planes, and the stresses along these planes are known as principal stresses. The plane on the which the maximum shear stress act are known as the plane of maximum shear. Okay, the plane in which the maximum shear stress is acting is known as the plane of maximum shear. Okay, so what is principal plane? In principal plane, there will not be any shear stress, and the direct stresses acting along these planes are known as principal stresses, and the plane on which maximum shear stress act is known as planes of maximum shear. Okay, so when a material is subjected to biaxial stresses, direct stresses in two mutually, that means if you are having a material, biaxial stresses means here we are having a stress mutually perpendicular, here also we are having stresses. Okay, this type of material is known as this type of load is known as biaxial stress. Direct stresses in two mutually perpendicular planes accompanied by a simple shear stress. There will be a simple shear stress. Okay. Then the normal and shear stress obtained are discussed below. So here will be what will be there as shear stress will be also there. So what is mean by biaxial stress? Direct stresses into mutually perpendicular planes accompanied by simple shear stress. Okay. That is known as that is known as biaxial stress. Then maximum principal stress is sigma is equal to sigma 1 plus sigma 2. Sigma 1 is the stress acting in x direction, and sigma 2 is the stress acting in y direction by 2 plus half into root of sigma 1 minus sigma 2 the whole square plus 4 tau square. Okay, so this is known as maximum principal stress, and maximum principal stress. So you have to understand that there is two types of stress. One is maximum principal stress and another one is minimum principal stress. Okay, so when you write the equation, sigma 1 plus sigma 2 by 2 plus or minus half into root of sigma 1 minus sigma 2 the whole square plus 4 tau square. So when here plus is there, what happens? Maximum principal stress will develop. When there is minus, what happens? Minimum principal stress will develop. Okay, so maximum principal stress is sigma 1 plus sigma 2 by 2 sigma 1 plus sigma 2 by 2 plus half into root of sigma 1 minus sigma 2 the whole square plus 4 tau square. Similarly, minimum principal stress is sigma 1 plus sigma 2 by 2 minus half into root of sigma 1 minus sigma 2 the whole square plus 4 tau square. Okay, so tau max is equal to sigma T1 minus sigma T2 by 2. That is sigma T1 divided by sigma T2 by 2 is equal to half of root of sigma 1 minus sigma 2 the whole square plus 4 tau square. These are the three equations. This is shear stress maximum, shear stress, maximum shear stress. Okay, maximum shear stress. Okay, that is sigma T1 minus sigma T2 by 2. That is half into root of sigma 1 minus sigma 2 the whole square plus 4 tau square. What is sigma T1? Maximum principal stress, and sigma 2 is minimum principal stress. So maximum principal stress minus minimum principal stress by 2 will give you the maximum shear stress. So actually, what happens when there is only one load here? In one direction only stress is, that means load is there. And in the other part, shear stress is there. There is no perpendicular force. Here only one force. The direct stress is in only x direction. There is no stress in the y direction. There is only shear stress in all the directions. Then what happens? Sigma 1 is there. Sigma 1 is there, but sigma 2 will be equal to 0. Okay. Any doubt? sigma 2 will be equal to 0. Then our above equation will reduce to sigma T1 as sigma 1 by 2 plus half into root of sigma 1 square plus 4 tau square. Similarly, sigma T2 is sigma 1 by 2 minus half into root of sigma 1 square plus 4 tau square. Similarly, tau max is equal to what? Maximum shear stress. Maximum shear stress is equal to half into root of sigma 1 square plus 4 tau square. Any doubt? Any clarification or any doubt? Okay, next what you are going to study is creep. When a material and a part is subjected to constant stress at high temperature for a long period of time. Okay, what happens? There is a material, okay, which is working at a temperature, okay, high temperature. That means 1000 degrees Celsius or 1800 degrees Celsius. Whatever, or you may say it is a higher temperature for long period of time. It is working at a temperature for that means for 5 years or 2 years, 3 years, whatever it may be. Okay. So what happens? It will undergo slow and permanent deformation. That type of deformation is known as creep. Okay. So the special why creep is important. We all are using vehicles now. Vehicles. The parts designed for the vehicles, when we design any material for the vehicles, it is important that creep should be considered. Because in the engine part, what happens? High temperature may be developed. Okay, so this material has to stay in that high temperature for a longer period of time. So this creep is very important criteria while designing materials for IC engines, boilers, turbines, etc., where high temperature will be developed. So what happens if this material is kept in the high temperature for a long period of time? What happens? Creep. That means slow or permanent deformation may happen. So when you're designing the materials which are undergoing high temperature for a long period of time, this creep criteria should be considered. Okay. Next is creep strength. It is defined as the maximum strength that the material can withstand for a specific length of time without excessive deformation. That is known as creep strength. You have to understand creep strength is nothing but it is defined as the maximum strength that the material can withstand for a specified length of time without excessive deformation. Okay. Creep rupture strength is of a material is the maximum strength that the material can withstand for a specific length of time. Okay. For a specific length of time, what is the maximum strength the material can withstand? It is known as creep rupture strength. Okay. Without excessive deformation, when we are using, it will be saying that creep strength, and this is the max of creep rupture is the maximum strength that a material can withstand for a specific length of time. But without excessive deformation, the maximum strength it can withstand is known as creep strength. Creep rupture means the maximum strength that the material can withstand for a specific length of time. Okay. Without deformation, when it is happening, it is known as creep strength. And when the maximum strength of the material that can withstand for a specific length of time, that is known as creep rupture. Don't get confused. Okay. Creep rupture is the maximum strength that the material can withstand for a specific. So in this creep rupture strength, deformation can happen. Okay. But in case of creep strength, deformation will not happen. Okay. When we are saying it is a creep strength without deformation only, we will be saying. Okay. If the deformation happened, it will be creep rupture strength. Okay. So here this is creep curve. Okay. So this is the instant elongation. So this is A to B. There will be some elongation. After B to C, the elongation or deformation will be increasing. After C, what happens? Up to D. At the D, what happens? The material will fail. Okay, material will fail. This is the importance of creep. Next is fatigue. Fatigue is when a material is subjected to repeated stress. So it fails at stress below the yield point stress. Such type of failure is known as fatigue. Okay. So what happens? The failure is caused by progressive crack formation, which are usually fine and microscopic size. This property is considered in designing shaft, connecting rod, springs, gears, etc. What happens when repeated stress is happening on materials? Okay. What happens? What happens when a repeated stress? It will cause some, that means it will cause some effect in that material, no? So when it happens for longer time, what happens? The material may fail below its yield point stress. Okay. So this is very important when we are considering designing a material in which repeated loads are coming, for a repeated stress are coming. Okay. For example, when you are designing a shaft, then connecting rod, springs, gears, etc. What happens? Different types of loads will be acting on this material. Repeated loads will be coming on this material. So when you are designing these materials, we should have an important criteria known as fatigue. Fatigue is when the material is subjected to repeated stress, it fails at the stress below the yield point. Okay. That means repeated stress are coming on that material. So it will not be able to attain that yield value. And what happens? It may break. Okay, so this value should be considered, this fatigue value should be considered while you are designing a material. It is very important criteria while you are designing a machine component which is subjected to repeated stresses. For example, shaft, connecting rod, spring, gears, etc. Okay. So I think the criteria is clear. Okay, this is very important criteria while you are designing a material which is subjected to repeated stress. Okay. So you have studied about different stresses. What are the defects in material? What are the different stresses you have to consider when you are designing a material? This is an important criteria when you are doing when you are designing a component in machine design. So machine design is a very important subject when you are saying about engineering or mechanical engineering, because when you are designing a machine components, there are so many criteria these machine components have to undergo. For example, connecting rod. Sorry, for example, an engine part, IC engine part. For example, an IC engine part. So this IC engine part is always working inside the vehicle in which the temperature will be very high. Okay, if you provide the lubrication facility, also there will be the temperature may be high. So this the material what we are using inside this IC engine should withstand all these things. So we have to consider different properties while we are designing this material. That is a creep, fatigue. Then you have studied how many. Creep is there, fatigue is there. Then what is there? What are the stresses? Bending stress is there, shearing stress is there, torsional shear stress is there, bearing stress is there, crushing stress is there, shear stress is there. So we have studied, we have gone through all these stresses. Okay, in these classes. Okay. So I think we will continue from the next class. So time is 9:30. Okay, thank you all. Okay, I think the concept is clear for you, no? Okay, when you study the next class also, I think we will be having a clear idea what is machine design, how the design is done. Okay, I think the concept is clear now. Okay, no? Okay, so I think if you have any queries, please ask me. Otherwise, we can wind up. Okay, I think no more queries are there. Okay, thank you. You can leave.
Yes, sir. Thank you.
Okay, thank you.
Thank you, sir.
Thank you.